Hello learners. In the previous lesson, we learned about mathematical expectation of discrete random variables. In this lesson, we will look into the expectation of continuous random variables. So, what is the definition of the expectation of a continuous random variable? If x is a continuous random variable with probability density function f of x, then the mathematical expectation of the random variable x, which can be denoted by mu, is defined as the integration of x times f of x dx over the limit negative infinity to positive infinity. Note that negative infinity to positive infinity basically indicates the smallest to the largest value that the random variable x can take. Let's look at a few examples now. For the first example, suppose x is a continuous random variable with a probability density function defined as such. What is the expected value of x? Looking at the PDF, we can see that f of x is equals to twice x when x is between 0 and 1 and it's equals to 0 otherwise. So let's calculate the mathematical expectation of x. So the expected value of x would be equals to the integration of x times f of x dx over limits 0 to 1, which is integration of x times twice x dx over limits 0 to 1, which can be simplified as integration over limits 0 to 1 of twice x square dx, which is equals to 2x cubed divided by 3 over limits 0 to 1, and that equates to 2/3. So the expectation of the random variable x defined with this PDF is equals to 2/3. For the second example, the probability density function of a random variable x is defined as this piecewise function, where f of x is equals to x when x is between 0 to 1 and 2 minus x when x is between 1 to 2 and 0 for x greater than or equals to 2. What would be the expected value of x? Again, let's do the calculation. The expected value of x would be equals to integration of x times f of x dx over the entire possible interval. Now, if we break this piecewise function down, we can see that f of x is equals to x when x is between 0 and 1. It's equals to 2 minus x when x is between 1 and 2, and it's equals to 0 when x is greater than or equals to 2. So we can break our integral down into integration of x times f of x dx with limits 0 to 1 plus integration of x times f of x dx with limits 1 to 2. We don't need to consider this third part because f of x is equals to 0 when x is greater than or equals to 2. So, doing the calculation, we have integration over limits 0 to 1 of x times x, which can be written as x squared dx plus we have integration over limits 1 to 2 of x times 2 minus x dx. Again, this can be simplified as integration over limit 0 to 1 of x squared dx plus integration over limits 1 to 2 of 2x minus x squared dx. So we have x cubed by 3 over limits 0 to 1 plus 2x squared by 2, which can be written as just x squared. So we have x squared minus x cubed by 3 with limits 1 to 2, which equates to 1. So the expected value of the random variable x defined by this probability density function is equals to 1. And that is how we calculate the mathematical expectation of continuous random variables.